All right, hello. Welcome to Physics Essentials Video 3.1. We're going to be learning about linear motion, is really the name of the whole unit. And then specifically, we're going to focus a little bit more on projectiles today. Before I get too far into this, I should also apologize. I am fighting off a terrible cold, so I may be a little bit sniffly, which I know is a little bit gross when it's recorded. So I apologize for my sniffling. So here we go, objectives. By the end of this video, you should be able to do these three things. You should be able to distinguish between and identify the 4 types of motion outlined here in the video. Secondly, when we're done with that, you should be able to explain what a projectile is and give some examples. And thirdly, you should be able to understand and apply the 2 rules of projectiles. Okay, so here we go. 4 types of motion. The state of Michigan, which has outlined the curriculum for this class, has broken motion up into 4 types. The first type is one-dimensional motion. This is pretty much what we've been doing up until now, all the motion we've talked about. In one-dimensional motion, the object is free to move in one dimension. All right, so it might be that the object is free to move on some sort of horizontal axis or some sort of vertical axis, okay? Or maybe even, maybe it's on a ramp or something, and so it's on a slanty axis. But basically, if it's in one-dimensional motion, the object can only move in 2 directions. It can either go forwards or backwards, right? Like if you're talking about a car on a road, this car can go forwards or backwards, one dimension. Or if you're talking about throwing a ball up in the air, the ball can go up or down. Or if you're talking about a cart on a ramp, the cart can go up the ramp or down the ramp, right? So those are all examples of one-dimensional motion. It's one line, okay? Sometimes people get confused about that if it's one dimension, why can it move in 2 directions, okay? One dimension means it's a straight line. It points in 2 directions, and so you can go either of those 2 directions. So examples of one-dimensional motion would include, I just mentioned these, a car driving on a straight road, or a ball that's thrown straight up into the air. Notice, if an object is moving on a straight line, the only way it can turn is to completely turn around and go the opposite way, right? This car here, if it's driving this way and it's limited to one-dimensional motion, the only way it can turn is to go back, okay? As soon as the car is driving this way and then turns that way, it's no longer one-dimensional motion because now you've got 2 dimensions, okay? Which brings us perfectly into the second type of motion, which is 2-dimensional motion. Now the object is free to move in 2 dimensions. So 2 dimensions means that you're going to have kind of an X direction and a Y direction like you would in math class, right? So your object could theoretically drive this way and then turn, okay? So examples of 2-dimensional motion would be a car on a curvy road, right? That's 2-dimensional motion. A ball being thrown up into the air, right? So you've got your dude, hello. Okay, the ball is traveling in 2 dimensions. It's not just traveling along a straight line. Okay, so in 2-dimensional motion, the object does not necessarily have to move in a straight line, and it can turn in any direction, right? A bird could swoop down and pick up this ball and carry it this way, and then this way or whatever. So as long as it's not going in a straight line, that is 2-dimensional motion. Okay, so the next type of motion we're going to talk about is called periodic motion. In periodic motion, the object is going to repeat the same motion over and over again at regular time intervals. All right. Examples of this would be a pendulum. Okay. The idea is a pendulum is this. It's a weight at the end of a string, and when you release it, the pendulum goes back and forth, back and forth, back and forth, back and forth. That's periodic motion because it's repeating the same motion at regular time intervals. Okay. Another example is if you take a spring and then hang a weight from it. If you stretch the spring out and then let it go, the spring will bounce up and down, up and down, up and down, up and down. Okay, so that's another example of periodic motion. Okay, so periodic motion is motion where the object repeats the same motion over and over again. All right. I should probably comment that notice also the pendulum is also 2-dimensional motion, right? Because it's traveling in a path that's not a straight line. But by describing it as periodic, we're being a little bit more specific and descriptive. So if I give you an example of an object and say what kind of motion is it, you want to give the type that is most descriptive, okay? The one that's most specific. And these are currently arranged in the video in order from least descriptive to most descriptive. So one descriptive, or one dimension, two dimension, periodic, and then the third one is circular motion, which is pretty self-explanatory. It's an object traveling in a circular path. So examples would be a car driving around a circular path, the Earth orbiting the sun, or the toy at the end of a rope or a string or something. So if you imagine, you know, letting a yo-yo drop to the end of the rope and then just whirling it around and around and around, then it's, you know, traveling in a circular path. Okay, a kid sitting on a merry-go-round would be another really good example, right? If you're sitting on a merry-go-round, you go around and around in a circle. All right. Notice anything that's circular motion is also periodic and two-dimensional, but again, by describing it as circular, we're being more specific. Okay, so there you go. There are your 4 types of motion. I always think it's weird that they didn't include 3-dimensional motion, but whatever. That's cool. So here we go. There are your 4 types of motion. Okay, so now we are going to learn about projectiles. So here we have the definition of projectile. Make sure you write this down. It says projectile. Technically, a projectile is any object in free fall. Okay, we've talked about this before. An object in free fall. That means the only force on it is gravity, right? So like I say, we've talked about this before. If you drop a ball, it's in free fall. If you throw a ball straight up into the air, it's in free fall. If you throw it straight down, it's in free fall. All right. However, usually a projectile also has some horizontal motion. Okay, so if you drop a ball or throw a ball up and let it come back down, that's a projectile. But like I say, usually a projectile has horizontal motion. So instead of just dropping it, we might throw it horizontally so that it goes like this. Or instead of throwing the ball straight up in the air, we might throw it at an angle, like passing a football downfield or something, so it goes like that. Okay? So anytime you throw or drop a ball or throw a ball in any direction, the entire time that it's in the air until it hits the ground, it's a projectile, because that entire time it's in free fall. All right? So keep in mind we're assuming there's no air resistance. All right? So when you throw a ball, think about this, you guys. When you throw a ball, the only force on it is gravity, right? When you throw a ball, the only force is the force of gravity. And if you imagine passing that football down the field, a couple things happen. One, it changes direction, right? It doesn't, you threw it this way, but it doesn't keep going that way forever, right? Because gravity is pulling it down and causes it to follow a curved path. Secondly, it changes speed. The football, when you throw it, is going to slow down while it's going up because it's working against gravity. And then on the way down, gravity helps it go faster and faster. All right? So it's speeding up on the way down and slowing down on the way up. All right? So notice that because of this, because it's got a curved path, it is an example of two-dimensional motion. All right? Notice also, or not notice also, I already said this, the projectile moves in 2 dimensions. All right, so the projectile has 2 sort of components to its velocity. All right, so check it out. If you kick a soccer ball, here's your dude, hello, soccer ball. Soccer ball is going to go like that, right? So suppose you took a photograph of the soccer ball when it was right here, okay? And I asked you, hey, what direction is the soccer ball going? You might point sort of this way, right? So it's kind of moving in 2 dimensions, right? Like I said, this is 2-dimensional motion. So there's an x-axis and a y-axis. And the soccer ball is actually moving along both of those dimensions, right? It's moving horizontally, right? Because it's moving down the field, right? But at the same time as it's moving down the field, it's also moving up, right? So this is the actual velocity of the soccer ball, but we can split that up into 2 what are called components. There's the horizontal velocity, which is, oh shoot, I should have done this in colors. So this bottom one down here is our horizontal velocity. Remember, horizontal means this way. Okay, so that measures, the horizontal velocity measures how fast the object is moving horizontally and completely ignores the vertical motion. It's kind of like if the sun was directly overhead and you watched the shadow moving across the ground. How fast the shadow is moving is your horizontal velocity. All right, and then the vertical velocity, which I've labeled here in blue, would be this guy. That's your vertical velocity. It's how fast the ball is moving up or down, right? Right now, the ball is gaining height because it's still going up. The vertical velocity measures how quickly that happens. And again, remember, vertical is this way, okay? If you're like me, I used to always forget which was which. Somebody told me this one day, that the horizon runs horizontally, right? So horizontal. Okay? Okay, so those are the two types of motion. So this is actually starting to get conceptually pretty difficult here, so if I lost you a little bit there, I wouldn't stress over it too much. Basically what you need to know here is the horizontal velocity, which I call Vx, tells you how quickly the object is moving left or right. Okay? And the Vy, the vertical velocity, tells you how fast the object is moving up or down. Okay? So let's learn the two big rules. So what's going to happen here? I'm going to give you the two big rules, and if I've managed to get this done correctly, hopefully we should have some videos inserted in here. That will help explain it. But regardless, when I see you in class next, we'll talk more about these rules and really kind of, drive them home. At this point, the main thing is you should know the two rules, okay? So write them down and sort of work on kind of memorizing them. And hopefully as we go through the unit here, we'll get to understand them better. All right, so the first rule says this. It says the horizontal velocity of any projectile remains constant. So remember, x means horizontal. So this little thing here is just saying there's no acceleration horizontally. All right. The idea is after you throw a football, there's nothing pushing it horizontally anymore, right? So the velocity remains constant. It doesn't speed up after you let go of it. It doesn't slow down after you let go of it. The horizontal velocity stays constant. Okay. So what that means is every second the ball is in the air, it's going to go horizontally the same distance. All right. The force of gravity will change the vertical velocity of the ball, but not the horizontal velocity. All right. Hopefully we should have a video here where we're going to see an airplane dropping some bombs. And so the idea is the airplane is flying along at whatever, 400 miles an hour or something, right? When it opens the bomb doors, the bombs fall out, but they're still moving at 400 miles an hour. So as the bombs fall, they move horizontally at the same speed as the airplane. And as long as this plane doesn't speed up or slow down, the bombs will always be under the plane.
And other smart weapons, mostly used for missions where volume, not precision, is required. It is capable of delivering cruise missiles and other smart weapons.
Okay, and that's showing you that the horizontal velocity stays constant. Tomorrow in class, I'm going to show you a similar demonstration with the skateboard to show you that the horizontal velocity is constant. All right, the second rule is this. All projectiles fall with a vertical acceleration of -10 meters a second squared, regardless of any horizontal motion they may have. So what that means is any projectile is going to fall down at the same rate, no matter how quickly it's moving horizontally. Okay, kind of the classic example is this. Imagine a fleet of cars driving off of a cliff. All right, and they're all driving at different speeds. So you've got one car that's going 2 miles an hour when it goes off the cliff, another car going 10 miles an hour, another car going 40 miles an hour, and another car going 100 miles an hour. And then the question is which one hits the bottom of the cliff first. It turns out they fall at the same rate. They all hit the ground at the same time because that horizontal motion, if this is your cliff and the car is going horizontally, all the horizontal motion does is affects the motion this way. It has nothing to do with the motion downwards. So the car that's going 2 meters a second, 2 miles an hour, is just going to go meow. The one that's going, whatever, 20 miles an hour is going to go meow. 40 miles an hour, meow. 100 miles an hour, meow. All right, but they're all hitting the ground in the same time, right? The only difference is how far it goes horizontally during the time it takes to fall. Okay, so there you go. Hopefully I've inserted a couple of videos in here. I'm going to shut up. Have a good day. I lied. I'm not going to shut up. I'm going to, right here at the end here, I'm going to tack on a Mythbusters video stolen without permission, so I apologize, Mythbusters people. You guys are copyrighted, so yeah, there you go. Credit is given. So anyway, in the video, they test this. There's a physics fact that if you were to fire a gun horizontally and at the exact same instant drop a bullet from the same height that you fired the gun from, both of the bullets hit the ground at the same time. All right, people tend to think that bullets don't fall, and that's not true. Bullets do fall, but the issue is they move horizontally so quickly, you're not really conscious of the fact that they fall, okay? And so they test it in this Mythbusters video by firing a bullet and dropping a bullet at the same time. And you can see in the video they hit the ground at the same time, okay? So I'm going to end with that. Because of these clips, my video is going to be more than 15 minutes today. I apologize. All right, there you go.
Right about there. That's where they were landing out in the shooting range, so this is where I expect them to land here.
Okay.
Adam lays down a runway of white paper so the high-speed camera will clearly see and measure both bullets at the same time, in the same place, and in the same shot. All we need now in the drop zone is Jamie's drop rig, so the boys can take a shot at physics history.
All right, dude, you ready to do this for real?
I think we'll hit it on the first shot.
Really?
Oh, yeah.
You never make predictions. That's awesome.
Bullet dropped versus fired. In 3, 2, 1.
But from 360 feet away, the boys can't see exactly where the fired bullet landed.
Let's go see where it hit.
So Adam takes a one-wheeled ride down the room to check out the drop zone.
Wow.
And the results are simply ripping.
Can't get much closer than that. Ugh. I can't wait to see the high speed. So, dude, this bullet carved a streak right under the drop zone. I think this might be the shot we've been looking for.
In real time, it's impossible to tell what happened until Adam analyzes the high speed and crunches the numbers.
3677 minus 3915 equals 238 divided by 6. Dude, the difference is 39.6 milliseconds.
Which means it's less than the human eye can make out.
So after days of brain-teasing tests, the Mythbusters can claim a world first for themselves and a victory for physics.